Okay, so let's go through all of this. I want to talk about what work I expect and what we need to do on our calculator for this. It's not a very long study guide, so I think we have time to go through the whole thing. The first one. So we have a null and an alternative hypothesis. Make sure you're labeling which is which. What variable are we talking about here? Mean. So our mu. The null is always equal. The alternative, this one we want to see if it's decreased, so less than. So B. Type 1 means you conclude H1. So it would be concluding the debt is less than $3,173, but it is not. Okay, an error means you made a mistake. So you have to say, but it's not, right? You made a mistake. Then part B wants type 2. So type 2 is when you conclude the null. So concluding the debt is $3,173, but we made an error. So you could tell me it's not, or more specifically, if we chose the wrong thing, the other was decreased, so it had actually decreased. Then our conclusion. I don't make you write a sentence on every question, but I will at some point on the test ask you to write a sentence explaining your conclusion. So you need to be able to do that. If the null is not rejected, there is not enough evidence to conclude that is less than $3,173. Did I prove that it was? No. In hypothesis testing, we're trying to prove the alternative. Okay? Failing to reject just means I couldn't prove that it was false. If we do reject it, we say there is enough evidence to conclude the debt has decreased. Why did I say decreased?
Because we're rejecting the
Yeah, my alternative was less than. All right, or that the mean is less than $3,173. So you should be able to do that on the test. Very similar to the study guide. You should be able to write your null alternative, labeling. You should be able to explain type 1, type 2 error, and you should be able to write a sentence stating your conclusion in any scenario. Is that okay? So number 2, null and alternative. It says the proportion, so I know I'm talking about P. Null is always equal to 0.733. Then the alternative, student believes the proportion is different, so different is not equal. Part B, that's the criteria. We have 2 options for criteria. If we're talking about a mean, it's one thing. If we're talking about a proportion, it's another. What's the criteria if we're talking about a proportion?
N times P times 1 minus P.
Okay. So my N, we talked to 100 people. My P, the 0.733, 1 minus P, and that's 19.577. So that's greater than 10, so we're good. All right, so you have to know the criteria. I told you did not have to do this by hand, so we can test on the calculator. So, on the test, we'll say stat, test, and I'll have a blank for you to tell me which one you chose. Then I'm going to say Z or T and P. So let's go in here. We have stat, tests. If I am talking about a proportion, do I want something involving a Z or a T?
Z.
Okay, so if you pick, do we have more than one sample? No. If you look at number 1, it says Z test, but if you select that, do we have all that information? It asks for a standard deviation. I don't have that, so I know that's not the one I want. So, if you keep going down, which one is it? Number 5. Okay. So I'm trying to kind of organize our information here. Our Z test. All right. So we are having a Z value. Our P of our null is 0.733. The X, what is my X?
78.
What's my N? Okay, be helpful to write those down on the test, just in case you make a mistake. I can realize that you were trying to put in the right thing, you just typed something wrong. So when I do that, it gives me my Z of 1.06. You can do more decimals if you want. P 0.2881. So then I expect you to state your conclusion. If I say state your conclusion, all you have to tell me is reject or fail to reject. So what are we going to do here? P is greater than alpha, so we fail to reject. When do we reject? When P is less than alpha. All right, is that one okay? So number 3, we need our null and alternative hypothesis. So the professor recommends them spend 480 minutes. Okay, I didn't come right out and say, is this a mean or a proportion? So how would you know? It's not a decimal, so it's not a proportion. Proportion has to be between 0 and 1. So the null is the mean equals 480. The alternative, we want to know if students are studying less. So that would be less than 480. What do we have to do here? Yeah, we have to put this into L1. So make sure you know how to do that. Do I need some of it in L1 and some in L2? No, everything here goes into that first list. Okay, I'm talking about a mean. We should verify criteria here. Right, it told me it was normal in the problem, so I don't have to worry about that. In general, if I'm talking about a mean, what is my criteria? Okay, so either has to tell me the date is normal or it has to be bigger than 30. And so anytime we are talking about a mean, are we finding a Z or a T? A T. Okay, so I know I need something with a T, so which one is it? 8 gives me a T interval, which is what I want if I ask for a confidence interval. Okay. So if I do that, I have to tell it data or stats. We have the data. The mean of the null is 480. Make sure your list is set to L1. Remember, we do change that sometimes. Frequency is always 1. We are testing less than, and calculate. And so it gave me that my t-value, negative 1.5768, or you could say negative 1.58, that's fine. My p at 0.07296, so I'll say 30. And then your conclusion, what would we say? P is greater than alpha, fail to reject. Is this helping? You know what I expect on everyone? Okay, problem number 4. So, null and alternative. We're trying to decide if the mean is more than 100. So, null is always equal, mean equals 100. Alternative, we're testing if it's more than. Criteria. What did we say our criteria was for talking about the mean? Greater than 30. Here my n is 35, so we're good. C, test it. I told you did not have to do anything by hand. So, which test would I go to? Talking about the mean, so we have to do number 2. Data or stats? Stats. So the mean of the null is 100. My X bar said my sample mean was 104.3. My sample standard deviation was 12.4. And my number was 35. We are testing greater than. So, mean gives me a t-value, 2.05. You can do more decimals if you want. Our p, 0.02399 or 0.024. Conclusion, alpha was 0.05. This time p is less than alpha, so what does that mean? If I asked for a sentence explaining this, what would that say? Yeah, there is evidence to conclude the mean is greater than 100. All right, so far so good? Number 5. You still have to have a null and alternative hypothesis because I'm trying to decide if the golf balls meet the standards. So my null, they're supposed to have a diameter of 1.68. So the null is the mean is 1.68. My alternative, we want to decide if they meet the standards. So what would that be? Not equal. Okay, so you need that. This time I'm asking for a confidence interval. All right, if I'm talking about a mean, am I looking for things involving z or t? Mean is t. All right, so stat test, which one is a t interval? Number 8. Okay. So do I have data or stats on this one? Data, although I should have entered it already, shouldn't I? All right. So if you want to practice, you can put this into your L1 real quick. So then we go into our test. I'm going to base it off data. List should be L1, frequency is 1, your confidence 7.95. So we get 1.6782 to 1.6838. Now I'm supposed to make a conclusion from that. So do these golf balls meet the standards? We're 95% sure the mean is between these numbers. 1.68 is in that interval. So we would reject or fail to reject? Fail to reject. The golf balls meet the standards. Number 6. The proportion. I just saw proportion, so I know my variable this time is P. Patients who visit the ER and die within the year is 0.05, so P is 0.05. A hospital administrator is concerned that his ER is higher, so that would be greater than. Conditions, if I'm talking about P, my conditions are N times P times 1 minus P. What was my N?
250. 0.05 times 1 minus.
Must be greater than 10, and it is. All right, part C, we test it. So, stat, tests. Are we looking for Z or T? Yep, proportion is always Z. So we need which one? Number 5. P of the null, 0.05. My X, my N, testing greater than, so my Z 1.3059, my P 0.0958. So what's my conclusion? Alpha was 0.01. So there's not enough evidence to conclude that his hospital has a higher rate. All right, part D, confidence interval. All right, we haven't done this one. So we need a Z interval. So if we look at our stat test, we have to go down to A. 0 is a 2 sample, so we want stat test A for the interval. Both of these, we do 1 proportion Z test, 1 proportion Z interval. So my X and my N are already in there. Confidence level, I asked for 99%. And so we get 0.02699 and 0.10901. Interpret it. What does that interval mean?
With 99% confidence of the proportion.
So 99% confident the proportion is between . If I were asking you to reject or fail to reject, my null was 0.05. So since 0.05 is in the interval, you would fail to reject. So that page, front and back, is basically chapter 10. That's everything with one sample. And I've got it at the end, I'll put this slide up. We've kind of taken some notes as we go. This is everything we've done if we're dealing with one sample. Now we have to talk about two sample data. Have we done two samples with proportions? No, everything was dealing with my mean, right? So let's talk about the two sample data next. So, question number 7. The very first thing to ask yourself is this paired data or not? And I kind of gave it a leading question on problem 7 because I said, why is this matched pair? So I already told you it was paired up. But why? What makes that paired up? Yeah, we took the arm span and height of one person. I didn't compare Abram's arm span to my height. Okay, I compared his measurements to his measurements. So do I need to write that down or yes? Okay. So B, if it is paired, the null is always dealing with the difference. Because if I do two separate things, it treats them as independent data. So anytime if it's paired data, your null is always the mean of the difference. Right? Then my alternative, we were testing if it was equal to height, so not equal. All right, the nice thing about this, if it's paired, we are no longer looking at two separate things, we're looking at the difference. So, refresh me, what do we do on our calculator?
Enter the data and then do the second one minus second.
Right. So you enter your data in the calculator. These are ordered pairs, so you do have to make sure they stay matched up. So you're going to put all of your heights in L1, all of your arm spans in L2. And then, because I don't want to look at these separately, I have to put them together somehow. So we go to L3, and we do L1 minus L2. Does everyone remember how to get that entered? Okay. So then, we're down to one set of data because we combine them. So we go stat, test, we're talking about a mean, we just have one set. So are we looking at a Z or a T? Mean is T. And that's stat test number 2. Okay, the thing you have to remember, the mean of the null is 0. We're basing this one off our data. List should be L3. That was caught a couple people yesterday. They thought they'd done something wrong. They just didn't switch their list to L3. Not equal, calculate. So when we do that, we get our T to be a negative 0.3924. That is very sloppy. And our p-value 0.7039. So since p is greater than alpha, fail to reject. Okay, so if it's paired data, all you have to do is find the difference, and then we're doing it the same as we were doing in chapter 10. Yeah.
So whenever it's the mean of the difference, like whatever has a small d, that's whenever you do subtraction?
Yes. D for difference, so we subtract one. Other questions? So that's if our data is matched pairs, if they are connected in some way. Number 8, I told you these are independent. Matched pairs is dependent, and dependent means they are totally separate. So if they are independent, then the null is always the mean of the first equals the mean of the second. So my null is just that. Alternative, we want to see if the first set is higher, so mean of the first is greater than the second. So B, this is when we get into a new test. Because I don't have one set of data anymore. So where do we go?
Four.
So if we go to that, this time am I doing data or stats? Stats. So make sure you enter it correctly. X bar of the first, so 48.2. Standard deviation of the first, 8.4. Number of the first is 45. For the second one, 45.2, 10.3, and 41. We're testing greater than and calculate. So anything with a mean is going to give us a t-value. So we get 1.4717. Our p, 0.0726. My conclusion, alpha was 0.1. So p is smaller than alpha. We reject. All right, part C, it wants the confidence interval. So, number 4 is just giving us our t value. If we want a confidence interval for the difference, where do we have to go? Stat, test, 0. Because we have two different statements. Okay, we have all the information is already entered in there. If not, you would have to put it in. Confidence level is 96%. Calculate. And we get -1.258 to 7.258. Questions there? All right, number 9. It tells me again, we have matched pairs data. If it's matched pairs, what's my null hypothesis? The difference is 0. I want to decide if the mean of the first group is smaller. So alternative. If the first one is smaller, what kind of number are you going to get when you subtract them? Okay, so clear out what you have in L1, L2, and L3. Because it's a difference, we will use all 3. So L3 is L1 minus L2. This one did ask you a question. I was really just seeing if you remembered how to use some other functions on your calculator. So you need to go into what? Do you guys remember? Stat, calc. All we really need is number 1 variable statistics, but which list do I want it based off of? L3, because I want the mean and standard deviation of the difference. You can get it other places when you run some tests, it does give it to you. but we were doing this back in chapter 2. If we were going to work out all these formulas by hand, we would have to get these numbers. So, does everybody remember how to get those?
Can we also just, as in our data, sometimes misses?
Yes, that's why I said some of the tests give you that in their result. So to test our hypothesis, which test am I going to? 2. Basing it off data, the mean of the null is 0, list 3, testing less than. So anytime we're talking about z, we get a t-value. And like we were saying, some of the tests give you that, and this one does, in fact. If you look down, the x bar and the standard deviation of x, is that the same as what we just wrote down here? Yeah, so you could have gotten it that way as well. Our p 0.2030. So p is greater than alpha. What does that mean? Yeah.
So is that how you, whenever you use the calc #1, it will say the d and will it say the s of x or s of d?
It'll say s of x.
So
I just knew this was the difference, which is what I put in L3, so that's why I told my calculator to use the third list. Confidence interval. So we're basing it off one set, so we just need to go to which test? We're looking for the confidence interval, so we're looking for the t interval, which I believe is number 8. We want to base it off the difference, so L3, 98%. So we get negative 0.7851 and 0.45176. All right. Is that one okay? Yes.
how come on the last one, when it asks for the confidence interval, it's like the first one minus the second?
Because that one wasn't it wasn't matched pairs. So these were just 2 different sets. Or sorry, this one was just 2 different sets. So your confidence interval is always based off the difference, and that's what number 4 does. We just have to
so
do
you don't
it.
have to like do it?
No,
Okay.
that's what your calculator on.
So to get the d, you have to use the stat calc 1.
Well, you don't have to, because if you run your test for this, so we were talking about some data, if we make it L3.
Yeah, I did.
Okay. It gives you the standard deviation there.
Okay, so it won't say d, it'll.
Right, it's just going to say X bar, but it's just meaning of the difference.
Yeah. Okay, thank you.
You're welcome. Other questions? All right. Last one. We want to know if there was a difference in comprehension depending on the type of manual. So, is this paired data? No, because I had different students in both groups. If I had the same student do it 2 different ways, then it would be paired data. Sample sizes were small, so what must be true about our population? Normal. That's our criteria. All right, B, null and alternative. Since they're not related, the null, mean of the first, is equal to the second. Alternative, the first, we are testing if there was a difference, so not equal to the second. C, so if I want to test that, we have to enter our data in L1 and L2. Do I use the L3 this time? No. So you're just going to go to stat, test. All right, if I have 2 different sets, we go to which one?
4.
Number 4, 2 sample t-test. That will give me a t value, which turns out to be 2.4085. My p is 0.0218. Alpha was 0.03, so p is less than alpha. What does that mean?
Rejecting all hypotheses.
Alright, and this one I asked for a sentence. We rejected the null, so that means there is enough evidence to conclude there is a difference in comprehension. Between the main.